Hi, I'm Philip. That's Nick. We're going to talk about measuring continuity. Before we start, I'd like to thank Emily for an awesome talk just before this. Going to save us a lot of explanation because she showed a lot of code that we can just talk about. So I'm going to jump right into it. We're actually going to try and push this to the limit, right? We work at Sosta. We work in an open source JavaScript library called Boomerang that measures performance in the browser. It sits in the browser, measures page load time as users' browser site, beacons it back to our servers where we do a whole bunch of interesting analytics on it. It's at github.com/sosta/boomerang. We love pull requests. Be warned though, the last few people who submitted a pull request got hired. So, why RAM? Why do we build this tool like Boomerang, and why do we measure real user measurements? Why do we measure things in the browser? So the cool things about RAM is it tells you what your users are really experiencing, right? It tells you right now what they're experiencing. You get data back to your servers really fast. It tells you how your users react to that. So Emily actually had a screenshot of our product, which we don't have. The Impulse product, where we actually correlate performance with business metrics like conversions and revenue, and RAM is the way to get that. It actually sits in the browser, tells you exactly what your users are doing and how they're reacting to their particular experience. It gives you fast enough results so you can react or, in fact, even be proactive to changes in performance on a page-by-page basis. So what does the user actually care about? When you're delivering a user experience, it could either delight the user or it could frustrate them. And that difference is really what's going to end up affecting how the user interacts with your site, whether they come back, whether they buy something, the value of things they buy, whether they click like on Facebook or don't like. Does Facebook have a don't like button now? So what does the user, how much work does the user need to do to accomplish a particular task? When the user does something, does what happens reflect what they expected to happen, or is it something completely different? So these are the kind of things that affect whether the experience is delightful or frustrating. And we want to try and measure that so that we can really quantify what that user experience was and how it affects not just performance, but business metrics, right? So we try to distill this down into three different inputs, really responsiveness. So when a user performs an action, how fast does your site respond to that? So like if a user clicks on it, do you actually react to that click immediately? When the user types a key, does that key show up on screen immediately, or is there lag? When the user scrolls, what happens? The second thing is smoothness. So again, interactions, especially things that deal with animations, if you're showing real-time analytics or you're scrolling through a lot of data, you're showing a video, how smooth is that, or is it janky, right? What's the frame rate? Those are things that affect a user's perception of your page's experience, so the page's performance as a whole, and that in turn will affect how they actually react to their site. And finally, cognitive dissonance or resonance. Essentially, when they try to do something, does what actually happens reflect what they expected to happen or not? So if it reflects what they expected to happen, it resonates with them mentally, and subconsciously they feel happy, they feel satisfied that what they did actually happened, or that they are in control. Whereas when there's dissonance, they feel like they're not in control, right? How many times have you gone to a site and done something, and like you click a link and nothing happens, or you try to type in something and something else happens? That happens to me all the time, and I curse the site because I'm a developer. I do Command-Alt-I, and I open DevTools, and I can see the JavaScript errors listed there. But my dad doesn't do that, right? He calls me and he says, what am I doing wrong? So that's cognitive dissonance, right? A user thinks they're doing something wrong, and that's a failure on the site developer's end. So we want to actually measure all of these things and then kind of quantify that in terms of delight or frustration. So what's the state of RAM today? Like I said, we're working on this tool called Boomerang and Impulse that measures performance, does real user measurement. We measure at this point everything up to the onload event, or rather I'd say navigation complete, because we also look at single page applications. When a user clicks on a link, we see how long it takes for that content to load up, and that's about it. At that point, we say, we're done with our measurements. This is what quantifies the user experience. We also measure whether a user bounces or not, which is kind of easy. If they go to another page, they have not bounced. If they do not go to another page, they have bounced. So just using those two, we correlate load time with business metrics. But the bulk of user interaction with the site happens after navigation is complete. Right? A user typically does not interact with the site when there's nothing on the site. They wait until the content is loaded and then start interacting with that content. And we do nothing to measure that. So this talk is going to be about what happens after navigation completes, how does the user interact with that, and how can we actually measure these things. So what we want to know now, we've already known for a while, for several years, that there are network characteristics, page load time specifically, and other things that navigation timing provides that you can measure up to onload. But which continuous variables exist after onload? And which ones can we measure? And how do we go about measuring? So that's what we're going to try and get into. I'm going to let Nick get started with some of this, and then I'll come back on.
So as Philip says, we want to try to measure the user experience after the page load, right? What kind of data can we get from the browser to help us understand that? So everybody probably has their favorite developer tools. These are Chrome developer tools. And you get all sorts of information from dev tools, right? On your local machine, we have this plethora of information available to us. It gets better over time. Every year there's more data that we get. Get everything from CPU information to frame rate to JavaScript stacks and heap information and all this kind of stuff. And for real user monitoring, we want to try to capture a lot of this data as well and bring it back to us, right? We want to get data from the wild and see what our actual users are seeing versus what we can see in the dev tools. But we can't get all this data in the wild. There's a lot of reasons why. As developers, we would lean towards gathering all of that, even taking a screenshot of that, right, from every single one of our users and getting it back to us. But there's reasons why we don't do that. A lot of this data has security, privacy, and performance reasons. And so we can't automatically just capture stack traces on every single JavaScript ever executed in the wild, right? There's performance downsides to doing that. The W3C recently published a technical note kind of explaining a lot of the trade-offs and why there's pressure to get more data from the browser and why we can't in many cases. But that's okay. There's still a lot of information available to us in the browser today. So let's take a look at the timeline view in Chrome, for example. In the timeline view, over time, you get to see things like frame rate, CPU usage, networking activity, memory usage. And we can actually get a lot of the same data, or a close approximation of this data today from JavaScript. We could package it up and bring the data back for further analysis, to look at what all of our real users are experiencing.
So does everyone know how to get to these screens in Chrome developer tools? All right.
So let's start with the first item. The first thing in the timeline view is FPS, so frame rate, frames per second. The optimal frame rate on most devices today is around 60 frames a second. This is because your device's refresh rate, how often the screen is painted, is usually around 60 frames a second. Anytime the frame rate drops below 60 FPS, the user is seeing a non-smooth experience. They're seeing stuttering, they're seeing jank. They're basically not getting a smooth screen. The good thing is we can easily measure frame rate in the browser, so even after the page is loaded.
Sharing the slide, right?
Yes, sharing the slides, and we'll have links at the end. Yeah, so don't worry about the code. If you want the code later, go check out the slides. We can measure frame rate in the browser today, even after the page load, by using something like request animation frame. Very simple browser API that is called immediately before every time the browser is going to paint. A lot of animators will use this in their games, right, to make sure that they have a smooth drawing experience. But we can actually just use it just to measure frame rate. Every time we get a callback, that's one more frame the browser has drawn. If we're measuring this over seconds, we get the frame rate, frames per second, essentially. Very similar to the frame rate overall, you actually kind of want to monitor long frames. So a long frame is anything that takes more than 16.6 milliseconds. This would mean at 60 frames a second, you get about 16.6 milliseconds worth of time per frame to do your stuff. Anything below that, and you'll start seeing the jankiness, the non-smoothness. So similar to just overall frame rate, you can count how many frames took longer than, say, 17 milliseconds. And those frames are frames where the user had a bad experience. Something stuttered, something didn't seem smooth to them.
So it's important to note this is not an average time, it is the maximum time you have.
Very similar to your overall page load experience, you can also monitor if you have any HTML5 video on your site, you can also measure the frame rate of the video itself. So in browsers, these are non-standard metrics, so Chrome and Frame actually have different counts. But you can essentially pull the video element to see how many frames were rendered over a period. And your video frame rate may be different than your overall frame rate, right? You might have a smooth experience, but the video frames are still coming in choppy, like in the middle of the screen because the network's slow, for example. So with these three things, we can essentially replicate the same data that we get from the dev tools, right? So we get frame rate, the lines over the top, the red bars in the top of the dev tools are long frames. Those are bad user experiences. We can capture all that from RUM today for every interaction after the page load. So frame rate's good. What's the next thing? CPU usage. Now, obviously, the dev tools give you a really good details about what's going on in the CPU here. You get CPU usage over time, what components are causing CPU usage, the layout and JavaScript and rendering and all that kind of stuff, and even stack traces, obviously, if you're doing profiling. We won't ever be able to get that kind of data in the wild. We shouldn't get that kind of data in the wild. It's expensive. There's privacy concerns and all that kind of stuff. But we can actually get a fairly close approximation of CPU time, and we're calling that page busy. So the idea is, if we're running something frequently at an interval, say every 25 milliseconds or every 100 milliseconds, we can see how often that callback didn't fire at the time that we expected. So if we set an interval for 25 milliseconds and it takes 30 milliseconds, it takes 100 milliseconds, we know that something else was running instead of what we wanted to track. That could be JavaScript, it could be layout, it could be anything else on the UI thread. But this simple interval that we're firing, we can actually measure what periods, how many periods within a second something else was running where we wanted to run instead.
So this is true because JavaScript is single-threaded, right?
We're calling this page busy. Relatively simple code to do this. You could probably get a little more complex than it. Check out the actual code later. But the core idea is we're running something at an interval. We're checking to see how long it took for that to actually execute. And anytime it doesn't, it's late, and we're calling that a busy period. We've seen this correlate pretty closely to the actual CPU usage if you're looking at the dev tools at the same time. It's not going to be the same. We don't have the same granularity. We don't get the breakdown, for example, of why. We don't know that layout or other JavaScript's running. We just know that we were late, and we didn't run at the time that we expected. And it's relatively lightweight for us to do this. All we're basically doing is setting a few variables every 25 milliseconds or so. Okay, so we captured the CPU, we captured the frame rate. What about networking activity? This is something where we actually have a lot of information available in the browser today via resource timing. So resource timing gives you all the resources that were fetched within the page, the URL, timestamps, DNS, TCP connections, all that kind of good data. Resource timing 2, which is being developed right now and is actually in Firefox today, I believe, has content sizes, transfer sizes, and decode sizes, so how many bytes, basically, of the content. And so you could actually calculate not only when the resources were being fetched from the network, but essentially your consumed bandwidth as well for a lot of these things. And finally, in this graph in the timeline, we also have heap usage. Emily touched on this a little bit before as well, but you can actually capture, there's a non-standard browser API to capture this in Chrome today. It's not available in other browsers. Chrome basically has the performance.memory.use.js heap size. And the number isn't super important. Like, don't focus on the number. The number can mean anything. Chrome, the devs have said, don't really focus on this metric. It's very granular. It doesn't update frequently. It's not very granular. It doesn't update frequently. But what you can do with this is you can monitor it over time. After every user interaction, if you see it going up quite a bit, or even over a long period of time, you could actually detect leaks in your application. You could also, by holding the device constant, like if you want to do performance regression testing, you could look at the heap from build to build to build to build to see how your application itself is getting more complex over time. So I wouldn't focus on the number itself, but I would focus on the change of the number either within your application over a time period or from build to build. And similarly, you can actually also capture battery metrics from your users in the wild. So anything that has a battery in it, you can basically get a 0 to 1 number for their battery level. This can be kind of interesting because you can actually make decisions on this. For example, if you notice that your visitor's battery is dipping below maybe 20 or 10%, you could actually turn off some of the functionality within your app to provide them a less mean experience, to burn down their battery less. So it gives you the ability not only to monitor it, but to take action on it as well. Okay, so we captured a lot of metrics so far, right? We replicated a lot of what was on the top timeline, not as precise as what you would get from the dev tools. Why are we doing this? Well, we want to measure user interactions. We want to measure what happens after an interaction with your app. Every time the user is interacting with your app is a point that they're looking at it, they're focusing on it, they're paying attention to it, and it's an opportunity for you to drop the ball, right? Every time the frame rate drops below 60 FPS when they're clicking or when they're scrolling, the user is noticing it, and they're probably getting a little upset. So it's important to be able to monitor and to know exactly when the user is interacting with your app, so you can pay attention to the period right after it. Luckily, we easily know when the user is interacting with mouse events, scroll events, clicking events, keyboard events in the app today. These are all incredibly easy to do. And it just gives you an important part of the timeline when the user is specifically known to be interacting with your app. On the flip side, you can also know when the user cannot see your app at all. So there's the page visibility API. This gives you a property on the document called hidden. If it's true, the user cannot see your app. So this could be if it's in the background tab, or if it's a background tab, if the browser's minimized, if the lock screen's up, for example. Those would all be cases where your page is hidden completely from the user. And it's good to know, and you can also get an event fired when that changes. So if they come from the background tab to the foreground, that's a good, that's the time when the user's looking back at your app again, potentially. And you want to provide a good experience at that point. There's also a new intersection observer API being worked on, which can also tell you when specific elements are within the viewport or not of the screen. And you can make some decisions based on that. And finally, you can actually also notice orientation. So for your tablet or something, you can know whether the device is in the portrait mode or landscape mode. And you could also notice, for example, if somebody loaded your screen in portrait mode and they didn't get the width that they want to search your site a little bit and they changed, you could get notified that they're actually changing the view. They're interacting with your site, you're probably relaying it out at that point. You want to make sure you give them a smooth experience at that point. So those are all many of the different ways that the user is interacting with your app, right? We have metrics like CPU and stuff to know what's going on. We have metrics when the user is interacting. And we also have, in the dev tools, for example, we also want to know about the document complexity. So the document complexity is basically how big is your app? How many bytes of HTML is it? How many DOM nodes are there? The more complex the app is, the longer the browser takes to render it, the more time it's going to be spending to get it to the screen. So it's important to track this over time. It's really easy to get the inner HTML length of the main document. You can count how many nodes there are, how many iframes, how many scripts, how many images. Those are all really easy to do with things like get elements by tag name. And looking at these over time, and especially after your user interacts with them, can really tell you what additional changes are required to swap in a view when they're interacting with your app. Similarly, it's also interesting not to know just the overall DOM node count, but how your document is changing over time. So for example, you could think of a carousel where the same, or with several different product images are coming into the main viewport. That's not actually increasing your node count possibly, but you're doing work. The browser has to react to them. The browser's taking time to draw and render and stuff like that. And we want to be able to know how much of the screen is actually getting changed over time. Mutation Observer is a lightweight performance API where you can get notified of all the changes to the DOM. You get notified of changes to attributes, new nodes getting inserted and removed. And you could do some simple math basically to figure out what percentage of the document is changing at any one time. So how much of the node structure itself has changed. And this just gives an indication of how much work the browser is doing to pay attention to what all the changes that you're making. And finally, error tracking is a really important thing for your users' happiness. Anytime that you're clicking or interacting and an error happens on the screen, you probably did something wrong. The user probably didn't get the experience out of it that they wanted. It's really easy to track on your own. You could pay another service to do this as well, certainly. But even just knowing that an error happened at all, especially right after an interaction, is pretty critical. So to prove that I'm telling the truth, we actually built a small Greasemonkey Tappermonkey script that basically monitors all of the metrics that I just told you about. So CPU, or page busy, frame rate, and all that kind of stuff over time. It just pops into any window. You don't need dev tools or anything like that. But this is basically all the data that you could gather from RUM. We're in real time loading this website, and I'm showing all the different metrics that we're capturing, including page busy. Let me give you a really quick demo if I can.
Yeah, you'll have to exit out of.
I don't know. I'm not going to give you a demo. Never mind. Animated GIF proves it, right? So this is available. We have an open source project if you want to take a look and just see how we're calculating these
the
things.
The repository is in the slides.
At the end of it.
Get that at the end.
Well, actually, at the bottom there as well. So I'm going to give it back to Philip, and we're going to say, who cares?
Yeah. So what we know how to measure all of these things which were listed on the inputs there: smoothness, responsiveness, and whether things are happening. How do we translate that into how the user has reacted, whether the user is happy with it or not? So we really want to measure that user experience to fill up that third component of our measurement, right? Smoothness and responsiveness, something we've looked at already, as well as reliability. But what about emotion, right? Do we have a browser API to measure how the user's feeling when they do all these things, right? Something like get emotions by tag name or something. There actually is something that came out in 99 or 2000 called mind reading markup language. Didn't see very broad browser support, but it's you should check it out. But anyway, there is this tool by Simon Hearn that just looks at frames per second during scrolling. So I'm not going to show you a demo of this right now. We're not going to rely on the network right now. But essentially, as you scroll through a page, measure the frames per second so that you know if things are happening and the site's getting janky at that point of time. That kind of jank can affect a user's mental state, affect whether they're happy or not. And it happens subconsciously. They don't consciously think, I don't like this, but something inside them says, this is problematic. It's hurting me in some way. An example, so this is a mobile site. When you click on that hamburger icon, it's supposed to scroll out the panel, but it's fairly janky. You see, it's not a smooth scroll. It's actually scrolling at there's several jumps in there. So this is the kind of jank that users don't like. That we as developers don't like. So it's how do we measure how users responding to this and what's really happening when they click on things? Is it really reacting like this or is it not reacting like this? So we measure frame rate. Responsiveness, so again, using request animation frame. Nick's already showed how to measure frame rate, but we also know that request animation frame fires when the browser is ready to paint something. So let's say the user clicks on a link or types in some text. We want to know how long did the browser take to actually react to that. We can use request animation frame on the event handler of that particular click or key press to see when the browser was next ready after that key press for drawing something on screen. We could also use mutation observer to see whether the DOM has changed, or use the intersection observer to see if certain elements have suddenly become visible. Like especially in a single page app, you click on a link, it doesn't actually reload the page, but it may fetch something and display that on screen. So you want to see if the DOM has changed. If the user clicks somewhere and nothing happens, or it takes a long time for something to happen, that is a problem. That's causing cognitive dissonance, that the user feels they're not in control of their experience. They've clicked, it's taken more than 100 milliseconds for something to happen, right? We can use user timing. So as a developer of your code, you know how long when you know different parts of your code, you know what's important for user interaction. So you can set specific time points to measure how long each of those took without actually using any of request animation frame or mutation observe. This is simply by knowing how your own site works and setting time points there. So this is an example of the responsiveness. On the click handler, we take a time point using performance.now and then set request animation frame to take another time point. And if the difference between these two time points is less than 16 milliseconds, then we say, all right, we're fine. In fact, I guess less than 50 milliseconds. How long does it take to blink? Does anyone know? You can blink 3 times a second, so I guess about 300 milliseconds to blink. So if it takes less than 300 milliseconds, yeah, it's happening within a single blink, so that's probably responsive enough. If it takes a little longer than that, the user's feeling something's wrong with this and I don't know what. JavaScript errors, we've already seen how to measure them, trending this over time, or just seeing when a user clicks on something or types in something or scrolls. If these things are changing, that's a sign that something's wrong that could be affecting performance. But really the big goal over here is to actually track emotion, right? Track how the user is responding, use that get emotions by tag name or get emotions by URL API that does not exist. So it turns out that there are several research papers on how to actually do this. First one is called rage clicking. Intuitively, does anyone know what rage clicking means? Right. It's very well described. There's a blog post and this quote from the blog post. It's almost like the user is punching your site in the face because nothing is happening, right? If that's not an indication that they're frustrated, I don't know what is, right? But we can actually measure rage clicks just by subscribing to the onClick event, and we actually have source code. Now, you don't need to read the source code. What's important is there's lots of colors and it's 20 lines long. Right? So it's actually very simple to implement a rage click monitor just to tell whether a user is clicking and nothing's happening. Are they clicking many times on the same link and expecting something to happen but nothing's happening? This could be an indication that either something looks like a link but it's not a link and they think something should happen when they click on that, or they are in fact clicking on a link but something's preventing that link from acting. JavaScript error, for example. You might have a link that has a JavaScript handler that's failing, and therefore nothing's happening. So tracking these kind of things and beaconing back to your server kind of tells you very quickly that something's wrong with your site, go and fix it because users are being affected right now. This is frustrating them. Related to rage clicks are dead clicks. So you click on something and nothing happens, right? It's not that you click many times, it's just they click and nothing happens and then they wonder, what did I do wrong? So it might happen during page load because you depend on JavaScript and the JavaScript hasn't loaded. Emily had a good example of jQuery not having loaded and that caused certain errors. Or there may be delayed JavaScript, or they may just, the network may have gone down, right? They may be using their phone and having to go through a tunnel at that point of time. And so they clicked and nothing happened. But it's important for you to know that. And there are ways around it, right? You can use service workers. You can build your app progressively to actually deal with these kind of outages.
And you can also detect it automatically in some cases by just looking to see whether the document changed after a click or whether there was any networking activity after a click. If there was neither of those, the user clicked on something that just, nothing happened.
Yep, it may not have been a link, but they thought it was a link. So this is an example video of Nick's Facebook page.
So this is Facebook loading at a 3G connection, and I'm trying to type in my status update, and I want to add an emotion to it, and I'm clicking, and nothing is happening at all until we're almost ready, so close. And then you see, oh yeah, now it's ready, right? So that's an example of the page looks ready, the visitor thinks they can interact with it, they're clicking on it, but nothing's happening. So it's because the JavaScript that works with that element isn't loading until a bit later.
Will that start again?
Yes.
All right. How do I go to the next slide now? All right. And finally, after rage clicking and dead clicking, there's also missed clicks, right? Sometimes your click target is just so small that someone can't click on it, right? I have fairly large fingers. If I try to tap on something on my phone, I often tap on the wrong thing. And that happens not very uncommonly. So the user clicks near an element but misses it. Sometimes they click on the wrong element. Sometimes they just click on something that's not a link. This is also something very easy to measure. Set a click handler on the document and look to see if a click happened near an element that is supposed to be clickable, right? That's an indication that your click targets are too small because the user is, in fact, trying to click on something. They're just not getting it. The next thing is mouse movement. So there's another research paper from Brigham and Young University, right? Mm-hmm. Yeah. It's inferring negative emotion from mouse cursor movements, right? So it turns out that people who are angry are more likely to move their mouse in a jerky fashion, right? And they move it, but they move it extremely slowly. Whereas people who are frustrated, confused, or sad are less precise in their movements and move it at different speeds. So just by measuring mouse movement, just subscribe to the on mouse move event on document and just look at mouse movements over time. And that kind of tells you what's the user state at that point of time. Now, it may not be directly related to your site, right? They might have come to your site already angry. And maybe you can do something to make them happier. Or maybe it's your site that's causing them to be unhappy. You can actually, tracking this over time will tell you whether their state is changing while they're using your site or not. These things might be a little more expensive because on-mouse move triggers very often. So you can also use something like event throttling, wherein you only fire the event every few seconds, or let's say 3 times a second. Even though it might fire very often, your handler will throttle to take the measurement at a lower rate. So that's a good way to tell whether a user is frustrated or not. And lastly, you can just ask directly, right? This is something that is at Heathrow Airport, I believe. When you've been through security, they then ask you, how was your security exception, right? Did you get frisked nicely? And you press one of those 4 buttons. So you could ask the user, and I mean, many sites do that, right? They'll pop up a little screen saying, are you willing to take the survey at the end of your browsing session? And how many of you clicked no? A very small percentage of people actually do not click no, either by accident or because they intended to click yes. One example was, do you want to tell the story?
Yeah, sure. So I was actually researching the company that has those little stands in Heathrow and stuff, and I went to their website, and this thing popped up. And I don't know about you guys, but whenever I see something like this, I just try to get it out of the way as quickly as possible, right? So I hit escape. Like that was my reaction. As soon as I saw this, I hit the escape key. Nothing happened, so I hit it a couple more times. Started getting angry, hit it a little bit more. Then I had to use my mouse, grab my mouse, use it, and try to go find the little X. Missed it, and then click the X. So I had a dead click, key press, because nothing happens when you hit escape. I had a rage because nothing was happening. I was getting angrier about it. And then I had a missed click because I couldn't get it out of the way fast enough. Like I wanted nothing more than to get this, to close this, and they made it extremely hard for me to do so. I don't know if they're monitoring that, but they should have.
And finally, eye tracking. So there's this pretty cool project called WebGazer. It's GPL-v3 if anyone is interested in knowing. But if you have it on your site, they actually provide an API to tell you where the user is looking. They use the webcam to detect eye movements. And that's another interesting thing. If you can see where the user's looking and see if their mouse movements are tracking where they're looking at. And then do they click on something? Are they looking at the important parts of your page or unimportant parts of your page? That can all help you in determining whether their experience is as they expect it to be or not. Now, clearly this is not good enough because it's only telling you where they're looking, not how they're feeling when they're looking. So if anybody's interested in updating this to do eyebrow tracking and maybe even like frown tracking, that'll be pretty cool. But ideally, what we'd want to do is like alpha and beta wave tracking, just look directly into their brains and tell whether users are happy or not. So that's all we have time for, we have a huge bunch of further reading items that you can go through to read more about measuring emotional state and continuous events in the browser.
We have all the source code for everything that we showed today.
Right down at this link here, we have the source code, and
eventually we'll be merging some of it into Boomerang,
right.
probably. But right now it's just kind of sample code.
Slides will be on SlideShare and probably Speaker Deck.
And we'll tweet those out.
We'll tweet them, so follow us on Twitter. Thank you.
The question is, does Boomerang require SOSTA? And the answer is no. SOSTA will collect all the data from Boomerang, but you could certainly do your own analytics. There's some open source packages out there, and we can tweet about those as well.
Yep, Eric.
You collect lots of cool data here. What are the data you found that your customers have used to make the most actionable decisions?
Okay, so the question is, there's a lot of interesting data here, and which of this data has been used by our customers to get the most actionable?
Which is data has been
most useful?
To actually make decisions off of, as opposed to just look at and say that's cool.
Okay, so I should say that all of the code we've shown today is experimental. We haven't pushed it out to any customers yet. The things that I think our customers find most interesting right now are maybe error tracking and just correlation of these kinds of events with their business metrics, like did a user convert or did they bounce? And again, which pages are more interesting than others?
And I don't know if you saw the machine learning talk earlier today, but all of these outputs would be great to feed into something like that and figure out the answer of what's most useful. Yeah.
So the question is, what's the overhead of measuring all of these things?
All of the code examples that we showed today are very lightweight. I mean, certainly as a monitoring product, we don't want to be getting in the way of it. Most of the stuff is simple polling, like once a second or something like that. You're really not adding much to it.
CPU and conflict.
Yeah, it barely shows up in stacks. All you're seeing is, you're keeping track of one counter basically. So one or two counters. So you barely even see it register.
Yeah, essentially
But do your own monitoring, obviously. Check that out on your site, make sure that's the case.
we collect the data during the event, so we just measure a variable, but we'll send it off, like beacon it to our server when the browser's not busy.
If you're measuring FPS using request animation driven, you have other callbacks also being scheduled with request animation driven. And the callbacks fluctuate. They won't always line up perfectly. It's just you have other stuff things to do.
Yeah, so the question is, we have a bunch of different things actually kind of running at an interval, and do they kind of conflict with each other in any case, right? You'd certainly want to pay attention to that. The nice thing is both of these scripts that we're showing, again, they're doing very little work. And you also kind of want to add a little bit of flub into your measurements as well. Like if they hit 59 frames per second, that's probably good enough. If the callback was, 26 or 30 milliseconds instead of 25, yeah, that's probably good enough. So there's definitely some, knobs that you kind of want to pay attention to and not be too precise about it. We're doing the best we can with the data that we got. We're not going to be able to get the precise data we get from DevTools.
Yeah, again, you'll want to look at this data in aggregate, so not just individual data points, but look at thousands of data points together and see, where the trends show up.
How are you storing this stuff? I want to say, traditional single page, they turn the beacon back on the unlimited and off you go. How do you keep storing all these things on an ongoing basis?
So the question is, how do we store this data? Do you want to know specifically about Impulse, or generally if you?
Boomerang,
Yeah.
the single web page. At the end of the event, the transfer
Yeah.
natural timings, and it all comes back in there. Wonderful. We're obviously looking at capturing things like frames per
Okay.
second, things that are ongoing.
Yeah.
Is that a single beacon? Is it augmented?
No.
in?
All right.
Or multiple beacons?
So
Storage indication.
yeah, Boomerang doesn't. So Boomerang by default will measure only up to onload, but you can also enhance it to turn on XHR tracking, in which case it'll beacon on every XHR event, or if you're using a framework, on every framework navigation. And in this case, we'd also tell it to just beacon periodically of this data. So Boomerang has the ability to beacon during the page's life cycle. It's not limited to only beaconing on onload. It also beacons on the unload event. So just before users leaving a site, it'll beacon whatever's left back to your server.
So are you storing those as separate beacons, or are they?
They're separate beacons. Now all the beacons for a single page can be tied together by using a UUID.
A session for a page almost?
Yeah.
Yeah, and the other thing is, you can use a combination of the send beacon API, which helps schedule beacons and make sure they reliably get to the system at the end of the day. And you can also hook into the page unload event as opposed to the page visibility hide event as opposed to the unload event to guarantee, if you do a send beacon in there, that the data is going to go out. So throughout the life cycle, you can be collecting this data, collecting the data, collecting the data. You don't have to send it out periodically unless you want more real-time measurements. But then you can, as good of a guarantee as possible, get the data out at the end of the entire page load process by doing the page hide and doing send beacon at that point.
So page hide is also a little more reliable because on mobile, there may not be an unload event. The way people close browsers is typically by killing it. If you just minimize your browser, it doesn't actually fire any events except the page hide. So looking at page hide is probably a good idea.
We are almost out of time, so we have a reception in the exhibit call, so please feel free to reach out to the speakers. And that's the last talk for today, so we'll see you tomorrow. Let's thank the speakers once more.